signs into it. Okay, we're gonna kind of take over where we left off. You want to have your packet open to page 30. Where you've got your formulas. We're dealing with the bottom half of the page. Okay, now we're dealing with the geometric ones. So you can see the column on the right are the geometric ones. Now, in this case, we've got this sequence. There's our a sub 1 term. We want to find the formula or the general term for this is what we're going to find. Just the generic, if you please. Now, in this, we have our formula, of course. The first thing we need to do is find our common ratio by dividing the second one by the first one, the third one by the second one, whatever. So here we have the second one divided by the first gives us 4/5. We try the third and the second, and although a little more complicated, we still get 4/5. So that pretty well confirms that our common ratio happens to be 4/5. Now, based on that, then we can simply write our generic formula for the nth term. 5, the first term. Here's the rule. The common ratio, n minus 1 power. Kind of wish they were all that easy. Hardest thing about this problem is remembering that formula. Any questions on this one? Pretty straightforward on scratching or question? Okay. Okay, in this one starts off just kind of backwards to the other one. In this case, you get a common ratio of 5/4 instead of 4/5. Okay. So our generic rule then is the first term times the ratio to the n minus 1. Basically the same problem as the last one, except the numbers. Okay, find the sixth term where the first is 10 and the second is 12. So this is kind of a two-step problem. We got to figure out the rule, and then once we find the rule, we can put in the sixth term. So we find the common ratio is 6/5. And in this case, our formula then would be first term times common ratio n minus 1. And here we have 10, which is the first term, and the common ratio, and then n minus 1. Well, if we want to know the sixth term, then we're going to replace this n with a 6. So 6 minus 1 is 5. That in turn is equal to this decimal value. Now, if you used your it equals that thing too. Okay. If you used your calculator, there it would be if you put it in there. All of you do that. No good purpose in having these calculators if you don't know how to put the stuff in right. Now, if you get a fraction, you may have to hit this standard to decimal key.
On the fifth, sixth, and you have sixth bit.
What?
On the calculator it says fifth, sixth, but on the board it says sixth bit.
Oh,
So
well, maybe we better fix that. That's a picture of one. So let me pull this thing up. I just put that in and I typed in backwards is what happened. Okay, so we've got 10. Thank you for catching that. 10 times, I've got to use the parentheses, the fraction key, 6, go down, 5, get out, parentheses, power of, and in this case, 5 equals. Okay, and then when I hit the standard decimal key, it should be 24, not 4. There. That's a little better. And to get rid of this and just replace it. Uh-oh. Remove the wrong thing. There. I'll have to resave that. Because it'd take me too long to save that in Photoshop and put it back in there with the correct calculator. Okay, there was the correct calculator on this one. Okay, this brings up the next one. I'll just leave it like that. First term is 64, second term is 16. So negative 16 divided by 64 is negative 1/4. So R is negative 1/4. First term times common ratio. We want it to be the sixth term, so 5 here equals 1/6. And then 1/16 is 0.0625 if you convert it to a decimal. Now, actually, you could probably do some calculating with this. 64 is 4 to the third, right? So if I took this negative 1/3 to the third power, then that would give me a value of negative 1/64. Do you agree with that? If I took just negative 1/4, just that number, forget that over there for the moment, I would get this. Okay, I've got this 64 out front. Right? Those two together equal negative 1. Agreed? Now, this negative 1/4 to the fifth is the same thing as negative 1/4 to the third times negative 1/4 to the second. You see where I'm going with this? Well, negative 1/4 to the second is 16, positive 1/16. So then bring that down. And your answer then is 1/16. So you get away with this with a calculator. If you do a little creative exponent manipulation, okay? And a lot of these kind of problems, you can do this sort of thing. Instead of just multiplying out huge numbers and then doing long divisions. Okay, on the find the first term and find an expression for the nth term, meaning the general rule, where the fourth term is -240 and the seventh term is 1920. This is kind of an ugly problem. Okay, this is going to take multiple steps. First thing we've got to do is we got to find the common ratio. Well, here's our general formula. If we put the fourth term in here, then this is going to be -240, right? So we're going to do that. Now, we're going to divide both sides by R3, R cubed. That's an R, believe it or not. So we end up in this case, these are out of sequence, obviously. 240 over R cubed equals the first term. But we still haven't found the common ratio yet. Okay. Well, the seventh term, when you put it in this formula, is this. We put the 1920 in here. We know that the first term is this business. So we're going to replace that with all of this. Like so. Now, 3 of these are going to cancel out 3 of those. Okay. Now we divide both sides by 240. And we get -8 is r to the third power. Well, if -8 is r to the third, then -2 is r to the first. Okay? Because cubic root of 8 is 2. Likewise with negative, since it's an odd root. Now, based on that, here is our common ratio. So have we found everything we need to do? Well, kind of. We haven't really got a number for the first term yet. So we need to actually get a number. Well, we're going to go back to this and substitute -2. And when we substitute -2 in there, which becomes 8, then just divide both sides by -8, and we get the first term is 30. That's kind of an ugly. Takes a lot of thinking, a lot of manipulation. Good one if you don't write it down, that you take a picture of. Okay? And, oh, they asked for the general rule. There it is. Ready? Okay, let's finite sum. Let's do some stuff a little bit easier now. Okay. This is the metric summation formula. Remember, the arithmetic one was you average the first and last, divided them by two, and then multiplied it times how many terms there were. Well, this is the geometric version of this thing. Okay. Now, we can do this as a summation. Okay. But in this case, we would have to do 7 steps if we did it as a summation. That sounds like an awful lot of work. And then add those 7 steps together. Well, how about instead using the summation formula? We know that the first term in this, if we choose 1 to get the first term, 1 minus 1 is 0, which makes all of this 1, anything to the 0 power is 1, so the first term has to just be 3. Did everyone follow me on that? How I got that first term? There you go. Okay. For the first term, we're going to choose 1. I put a 1 here, which gives me a 0. Anything to the 0 power has a value of 1. So that means you get a 3. Then is 3. The common ratio is that negative 1/3 based on the formula. Okay. Now, we can use this formula now that we know what R is and what the first term is. So we look at this. We put in the 3 for the first term. 1 minus, that's 1/3 to the 8th power. Not something you'd want to do by hand. Okay. And here, 1 plus 1 is 1 minus R, so minus a negative gives us plus 1/3. This simplifies farther to that. And in this case, we would leave it at that. Okay, yes.
How did you formulate the S to the 8th formula?
How did I formulate it?
Yeah, is it one that we should already have on our sheet, or is it?
It is.
Okay.
Look at your sheet. Metric side should be actually the second formula you have on the geometric sequences. S sub n equals A sub 1 times 1 minus R to the n over 1 minus R. Yes.
I'm sure, like, obviously not even done yet, but how many of these would we need to memorize?
All of them. They could use any of them.
Gotcha. So any.
Okay. The primary ones that you need to know are these 2 addition and those 2 geometric.
So the arithmetic and the geometrical.
Yeah. Those are the ones that you primarily need to know. You need to know how to do a summation where it has the limits. You very well could have a problem where they have to do that. Okay, that's just a matter of evaluating 1, then 2, then 3 to whatever the upper limit is, and adding them all together. Okay. All right, this one. Find the sum of this. if we tried to use summation, we would end up having 7 steps to do it in. Using this formula, we would have the problem to begin. Now, you actually do this using your calculator. For some reason tonight, every time I input it, I get an error, input error. So I don't know whether there's something wrong with my computer or whether it is. But if you put this stuff in exactly as I have it there, you should get this value. Likewise, if you put this stuff in exactly as that happens to be a 3 there. Exactly as I have it and hit equal, you should get the same answer. Like I said, for some reason on my computer version of this, it's not working tonight, even though I did this on that computer, on that computer model originally. So I don't know what's going on with it right now. Now, keep in mind, if you put something in a calculator, you put that on paper too. But doing it by hand, this is the way you would want to do it, because you only have 1 calculation instead of 7. Although you would have smaller individual calculations with this, although 1/3 to the 6th power is not necessarily going to be much fun.
For the X, did you just do alpha and then the?
I did alpha and right here. Thank you for asking. And for the summation, I did shift and right here.
That's just there.
Yeah.
No,
You got it right? Okay.
I typed it in the wrong.
Well, the input errors are an extreme likelihood on these kind of problems. What?
Especially when you're dealing with a bunch of parentheses.
Yeah. And anytime you have an opening parentheses, you better have a closing one. By the way, the summation key, I have never gotten it to work on arithmetic ones, only on geometrics. Okay, everyone at least tried these? Anyone have some success finally?
I wasn't putting the bottom part of the fraction or the bottom part of the.
Oh, well, that would matter.
Yeah.
That would
I was
matter.
only looking at the first calculator though.
Make sure you use not the divide, but the fraction, because those are 2 different things.
Yeah. That fraction key is your friend. Okay, so here we go. Find the sum. Again, you can do it this way. They're going to show you do it as a sum. Well, they're going to get lazy on you. They're not actually going to do all of the terms. First, they're showing you what the first 2 would look like and what the last one would look like, but you would technically have to have all of them in between. So not necessarily a good plan. So instead, we'll go with this. Okay. And the trick they're pulling here is they are figuring out the numbers on these, and then they're treating it like an addition one. On this one, you really shouldn't. Now, let's go to this one. Here's our tool. Remember, that's not imaginaries. Try that in your calculator and see what you get.
Where'd you get the 25/6?
Hmm?
Where'd you get the 25/6?
Actually,
Oh,
adding up all of these, you got to do a common denominator thing.
Over 6.
Well, I'm not erasing anything yet.
Yes.
You agree with those simplifications?
That.
Okay. Common denominator looks to me like it's gonna be 18. So this would be 36 over 18. Plus 18 over 18. Plus 12 over 18. Plus 9 over 18. Okay, 36, 46, 54, 64, 66, 75. Okay, 3 will go into both of those numbers. Okay. Now, have you put that into the calculator?
You're putting the anything into the
Oh, no.
calculator?
Well, you can try it if you want to. Go ahead and try it if you want to. And see what you get.
I got my thoughts.
You got 25 over 6. Okay. Whoops, wrong button. Shift summation of fraction 2 x go down over x squared. Whoops. Ah.
So do you?
I tried a shortcut that didn't work. Okay, alpha x. Well, what did I do? I didn't hit alpha, I hit the shift x alpha squared out of there from 1 to 4. Okay. Equals 25/6. Yes.
So like this problem, like you're gonna work both that SM equals on the
What?
with the circle and you're gonna have the,
I mean, let's compare doing it this way and compare doing it that way.
so you can do either or.
Should be able to, yes. So in this case, I've got a fraction to start with. A sub 1 is, what did I say? A sub 1? A sub 1 is 1. Okay. One. Parentheses. 1 minus. Okay. Common ratio on this one is, what did I say I had? Here I had 4 over 4 is 1. Here I had what did I erase some? Oh, 2 is my first term, 1 is my second. So I took half of that. This isn't a geometric. This is an arithmetic. Because you can't get a common ratio. It doesn't go the same.
So for this problem, you just use the limit x equals.
Yeah.
That would be the sum of terms.
Yeah, sum of terms.
I think I made
Okay,
so now.
here's another sum of terms one. This one. Let me get rid of my old marks. I'm not a professor, I'm a mister, but go
Sorry.
ahead.
Yes. I think I may have zoned out at the end of class last time, because will the problems on tests specify the difference between arithmetic or geometric?
No.
Or is there a way to tell at first glance?
Yes,
Can
the
you
fact is,
explain
we
that?
did that yesterday.
That's what I'm saying, I'm pretty sure I'm zoned out at the end of class.
Well, basically, you compare the first 2 terms.
Okay.
For arithmetic, they add the same amount from term to term to term, then it's arithmetic. If there is some fraction or multiple, okay, that you can multiply this term to get the second one, multiply that fraction to get the third one, multiply that fraction, that would be geometric. Okay, that's the rule. And there is no easy way unless they tell you, okay, on these. Now, if we look at this one, we're going to multiply this first term we've got, multiply it out, Okay, we're starting with 3. So 3 plus 1 makes the 4. Okay. And then over here, we would have a 3 again. So we multiply all together and we end up getting 9. Here, 4 plus 1 is 5. And here is a 4. 4 times 3 is 12. -1 to the 5th is -1. So this is -12. Here, we've got this one, our 6 there, 5 plus 1, and our 5 there. And get the 15. So 9 minus 12 plus 15 gives you 12. Yes.
So like for this problem, so like the SN equals the whatever circle in red, we just ignore that because
On this problem, ignore that.
and the last one as well.
Yes.
Okay, all right.
Yeah, these are supposed to be all geometric, but they're not. And why it worked out that way, I'm not absolutely sure. Well, here's another one. This one, you're just going to evaluate it. 10 to the first is 10. And you got it 4 times 40. This one, here's 3 different problems. You can see how they work out using the summation stuff. Basically, this is the way you're going to do it. Or you can bring these down vertically like I showed you the other night. Oops, I thought I went too far back, but I guess that's as far as it went.
I'm good now. Thank you.
Okay. Here's another one, worked vertically, like I did the first night that we did these. And again, this thing up here, you really shouldn't be using on this one. Now, again, here's just a calculator example using it. Notice this formula right here. That is the multiple formula. Either one of those 2 formulas would work, give you the same results. You don't need to write any of this down. Okay, you don't need to write this down. You're not going to have problems like these. And we've actually done this problem before. Here's one that would be more like what you would have on your test. This one might be worth copying.